Hello everyone. So in this video, we will learn about a new package called NumPy package. So NumPy package is one of the package which is available in Python, which basically stands for numerical Python. So numerical numerical Python. So the usage of this package, especially, it's very useful when we have a large complex data set and we want to do a lot of heavy loaded mathematical operations on top of it. So that's where NumPy package is super useful, super efficient in doing a lot of different mathematical operations, such as we are doing some operations on linear algebra or log on some huge big data sets of gigabytes or terabytes. So the way we can use this NumPy package is through this command import NumPy as NP. So NP again is a alias for shorter form of NumPy. So whenever we need to use NumPy, we will use the short word as NP, only NP. Instead of writing the 5 characters NUMPY, we will use only NP. So in the NumPy, we have a couple of data structures. So one is a NumPy array. So NumPy array basically store the elements of similar data type. So if you have integer values, it only store all the values of an integer data types. If you have a string, it will store only the string. But the thing is that if you have seen in the list can store values or elements of multiple different data types, whereas arrays, as I said, only store values of similar data types. Now, as we know that, as I mentioned, that NumPy arrays are very powerful when we have a huge data set and we have to do multiple different mathematical operation. That's where I think NumPy is very efficient and way better than using the list. So let me show you some example. How can we create, use NumPy? What are the functions are available in the NumPy package? So let's see a couple of examples on list. So here I have created two lists, sports underscore list and number underscore list. So in the sports list I have 3 values: soccer, tennis and basketball, whereas number list has 5 elements: 4, 5, 6, 7, 8. Now what I'm doing here, I'm just printing let me restart and clear all those. So here what I've so let's understand in terms of list first. So first I have created a 2 list. So there are 2 lists are there. First is the sports list, which is soccer, tennis, basketball, and the second list is number list, which has values 4, 5, 6, 7, 8. And what simply I'm doing is printing those values as well as their data type. So printing their values here, sports list, and its data type. So as you know that we can print the data type using the function type. So when I run it, I can, as you can see, the sport list, it displaying the values of sports list as well as its data type. So list, we can see it has a list. Now let's understand how can we convert this list into a NumPy array. So it's very straightforward, very easy. So the way, as I said, we will use the smaller name np dot array. So basically we are converting into a NumPy array. So this is one of the function available in the NumPy package, np.array, and then I'm passing a sports list. So this is the sports list, I'm passing the sports list, and what I'm doing in the print statement is just printing the value of the sports array as well as its data type. And similarly I'm doing with the second list, which is a number list. Okay, so let me run this package again. Okay, so make sure that you import this package as well as run this package, so that only you can use the functionality of a NumPy package. So when I run it here, we can see that sport array is the soccer, tennis, basketball, and its data type is NumPy array. So we can see that this particular variable has converted into a NumPy array. Now, as I mentioned that NumPy array only store elements or values of a similar data types. Let's say while converting from list to array, list can have values of a different data types. Then how NumPy array will behave in this scenario? So let's say this is a list called mixed list. It has 2 values of a different data type: soccer, which is string, and 2, which is integer data type. So in this, I'm just printing its values and its data type. And the next is a mixed array. Here I'm converting this mixed list into a NumPy array. So let's see what output we will get here. So mixed list is soccer2 and its data type is list. Whereas for mixed array also we are getting the same, but the thing is that since array only store data type of a similar type, it has converted soccer and 2. If you see the single quotes, soccer and 2 into a similar data type of a text. Obviously, Python cannot convert soccer into an integer data type, but it has converted into a string data type. So now soccer and 2 both are string and their data type is NumPy array. So we can see now that mixed array is storing the values of a similar data type. Both are string values. And same concept of list we can replicate in the case of a tuple as well. So here I'm doing the same thing. And even while converting from tuple, which is this soccer2, sorry, I think I given the wrong name. It's mixed list. It's basically a tuple because we can see it has some circular brackets in it. So it's basically storing a tuple. And we can see that its data type is coming as this one tuple, and it has converted into a NumPy array and both the values of a similar data type. So list and tuple will behave exactly similar when we convert into a NumPy array. Now like NumPy array, we can have a NumPy 2D arrays as well, or we can say NumPy matrix. So NumPy matrix are two-dimensional arrays, rows and columns, same like our spreadsheet where we have multiple rows and multiple columns. Here we can say in the case of NumPy package is NumPy matrix. So let's go in a similar way. Let's create a first two-dimensional list which has multiple rows and multiple columns. And as you know that the way we create a 2D list is inside the square brackets. I'm passing this first list which is 1, 2, 3, which is our first row, or we can say 4, 5, 6 is our second row, and 7, 8, 9 is our third row. And then I'm printing the values of list2d, and then list2d 1, 0 is just printing out the values which is present in this location. So when I run it, I can see that output, and it's saying that row 1 column 0 has value 4. So let's say let's convert into this 2D list into a NumPy matrix. So the way we can do is the same thing, np.array, pass this 2D list, and it will create a NumPy matrix or a 2D array. Now here we can see that, see the view or the here 2D list, it's difficult to view the 2D list, whereas in the output of a 2D array, it's much easier to see or understand the values of a 2D array. So here I can easily tell that, hey, this 1 is present in 0, 0 location, means row number 0 and column number 0. 2 is present in row number 0 and column number 1. And 3 is present in row number 0 and column number 2. So if somebody asks me, hey, you have 2D list and 2D array, can you tell me what value is present in row number 1 and column 0? Here it will be little confusing, not easy to tell. But here I can easily tell, hey, okay, you are asking row number 1, this is 4, 5, 6, this is the row number 1. Now you're asking for column 0, so column 0 is this one. So row 1, column 0, it's 4. So I'm expecting the output should be 4. And then we can see that the output is coming 4. Let's understand that the examples what we did so far. We have created list first or tuple first, and then converting into a NumPy array or NumPy matrix. Now let's understand the situation or a scenario where we want to create a fresh NumPy array or from a scratch. It should not be from a list or some different data structure, but I want to create a NumPy array from a scratch. So for that there is a function called np.arrange. So arrange function is one of the functions which we can use to create a NumPy array. So for that we have to pass 3 parameters. So arrange, and make sure that in the arrange word there is only 1 R, no 2 R, only 1 R. So then there are 3 parameters in it, x, y, z. X stands for a start value, from where you want to start your value, like your values inside that NumPy array should be start from 0 or 2 or 4 or 5. You need to provide some starting number. If you don't provide the value of x, by default it will start equal to 0. Y is the end value. What is the range of values like you want to end? And remember one thing, and this is mandatory, you have to provide the end value. And this is one important thing, is that if you provide y equal to 10, let's say the end value y equal to 10, then Python will go till 9. So it will exclude 10 and it will pick the number before it. So in the case of 10, the Python will go till 9. So it assumes that the number you want from till 9. And z is the step size, or a default step size is 1, but if you provide some step size of let's say 2 or 4, it basically telling how many incremental you want. So for example, let's say in the example np.range, we have given 0, 6, 2. So 0 would be our starting value, 6 would be our end value, and 2 is the step size. So as I told you that 6 is excluded and it will pick a number before it, that would be 5. And based on step size or an incremental size, it's 2. So the values we are expecting to be start from 0, then 2, and then 4. So the output would be 0, 2, 4. So basically we have created a NumPy array which has 3 values in it, 0, 2, and 4. Now let's understand a different scenario. Let's say instead of passing the 3 parameters, I am passing only 2 parameters, 0, 6. So by default, so we have given the starting value is 0, so it will start from 0. We have given the end value 6, so as you know that 6 would be excluded and it will run till 5. And we have not provided the step size, so it means that by default the step size would be 1. And we can see that we have created 6 elements. We start from 0 and goes till 5. So 0, 1, 2, 3, 4, 5. So this is another NumPy array what we have created. And similarly np.arrange 6. So since we have given only one parameter, so it means Python will by default assume that 6 is your end number, your default start number would be 0, and your step size would be equal to 1. So we will expect to get this element 0 to 5. The next function what we will going to learn is np.zeros. Now before in the arrange function, what we were doing, we were creating an array and we are passing some values. So some values would be there or some non-zero values would be there based on certain condition, based on a start value, end value, or a step size. But let's say we want to create a NumPy array which has all the values filled with zeros, all the rows and columns filled with zeros. In that case, we can use a zeros functions. Now in the zeros function, what we basically provide as a parameter is we provide the number of rows, how many number of rows we want. Then we provide the number of columns, how many number of columns we want, and then we provide the data type of it. So we want data type to be int or float, or what would be the data type. So let's say I'm creating this NumPy metric mat1 and np.zeros, and then inside it I'm passing 2, 4. So since I have not provide this d type or a data type, by default it will take it as a float. So when I run it, it has filled all the values, so 2 rows and then this 4 columns, and all the values had been filled with zeros. And since we have not provided any data type, so by default it's taking the data type as float. Now let's say in the next example, I'm creating a np.zeros with 2 rows and 4 columns, but this time I'm providing the d type to be equal to int. So data type has to be int. So in that case, we can see that there are 2 rows and 4 columns, and all the values are coming to be integer data type. So there are no float decimal values in it, as compared to the previous one which has some decimal values in it. And similarly, I can also provide a string data type. So all the values here would be blank. So all the values will come as a blank. So in case if you want to create a NumPy array or a string NumPy array which has a blank values, so we can use this command as well. So the next function is np.once. Now np.once work exactly same like zeros function. The only difference is it will fill all the values with ones. Instead of zeros, it will fill all the values with ones. So, and the rest of the format of ones function is exactly same like zeros. So we can see that since we have used np.ones function, np.ones, so it is filling all the rows and the columns with the value of 1. Again, the same thing, since we have not provided data type, so by default it will take as float. Now in the next example, we are passing the data type as int. So we have created a excuse me, we have created a NumPy metric and filled all the values with 1, which has a data type of 1. And here also we have created a NumPy metric or a string NumPy metric. Here, since we are passing a data type as string, and all the values have been filled with a 1. So this 1 is not a numerical value, it's more like a string values. So the next function is np.I. So I, E, Y, E, but when we say I, it's I. So I alphabet, which is I, identity metric. So basically it's the identity metric. So what it will do is that whenever you create any metric, so the diagonal values will all be filled with 1, and rest of the non-diagonal values will filled with 0. So let me give you an example. Let's say I'm creating a np.I, and here we pass two parameters. One is the shape of the metric, and make sure when we pass 3, here we pass 3, it means we want 3 rows and 3 columns. And since we have not passed any data type here, so assume it would be a float. And we can see that it has created a 3 by 3 metric, 3 rows and 3 columns, and its diagonal values are all filled with 1, and rest of the values are filled with 0. And same, if I provide a data type of int, it will create a new metric 3 by 3, 3 rows and 3 columns. Diagonal values are all one, data type of int, and the rest of the values will be filled with zeros. So now the next function is a reshape functions. So reshape function can be useful when we want to convert from one form to another form. What I mean that sometimes when we want to convert rows into columns and columns into rows, we can use a reshape function. So for example, let's say I'm creating a array ARR NumPy metric which has two rows and 4 columns. So whenever we write something before the comma, that will always consider as rows. Something which we write after the comma, it's representing columns. So first we mention rows, which is 2 here, and then we provide column number of columns, which is 4 here. So here I have created a 2 rows and 4 columns NumPy metric, and all the values are filled with 1 because we have used ones function. Now I want to convert this 2 rows and 4 columns. So they have 2 rows and 4 columns and reshape 4 by 2. So it means I want to reshape into 4 rows and 2 columns now. So when I reshape, now it becomes 4 rows and 2 columns. So this is how we can reshape from one form to another. Let's say I'm creating another NumPy array which has using the arrange function. So 1, 9. So I'm expecting 8 values, 1, 2, 3, 4, 5, 6, 7, 8. So 8 elements. Now let's say I want to reshape 4 and 2. So it means I want 4 rows and 2 columns. So when I reshape from one dimensional array, which is 1, 2, 3, 4, 5, 6, 7, 8, to a 2 dimensional array, this is the value we will get. So 1, 2, 3, 4, 5, 6, 7, 8. Now here is the most important part here. Make sure when we are reshaping from one form to another form, we must have equal number of elements in both. It cannot be done in this way. Let's say here I'm creating a one dimensional array, NumPy array, which has 8 elements from 1 to 9, and we know that total number of elements are 8. Now when we are using the reshape function, we are passing 4, 3, which means 4 rows and 3 columns. So it means 4 rows and 3 columns will become 4 into 3 equal to 12 elements. Now our original array has only 8 elements, but the reshape elements we want to have 12 elements, which cannot be possible. So it has to be equal. So if I run it, it will throw an error that cannot reshape array of size 8 into shape 4, 3.